Hello everyone. This class is actually continuation of the topic we have started before, that is integration by parts. Formula you all know. Still I am writing it, but with the application of the formula we are going to do, many more different kinds of sums can be done, that I am going to show you one by one. That if product of two functions are there, then its integration will be like this: fx into gx dx minus derivative of fx integration of gx dx whole dx. The kind of sum we are going to do now, where the integrand is of this form, say I is equal to just integrate this type 2 to the power x cos x. Okay, obviously we are going to follow the Eilert rule here: inverse, logarithmic, algebraic, trigonometric, exponential. So when you are going to solve this kind of sum, this falls under the category of exponential function. Cos x is the trigonometric, so cos x will be first function. But as I told you earlier also, that this will not terminate integrating after once, and whatever you take first function or second function, it doesn't matter. You can take any one of them first or second. Okay, so I am following this rule initially, that 2 to the power x cos x, trigonometric, then exponential, cos x will be first function. So use by parts to write cos x, 2 to the power x integration, 2 to the power x by log 2 base e, of course, minus sin x. See, sum is not changed at all. Why? Because the term which you are supposed to integrate, it has taken another form here: 2 to the power x log 2 minus 1 by log 2 into sin x to the power x. So I will be equal to 2 to the power x again apply by parts on it by taking sin x first, 2 to the power x by second, minus cos x log 2 base e. I am writing just to remind you. In exam, if you don't write, it doesn't matter, because when you don't mention any base, it will assume that base is exponential. Automatically it is. These bases are e. You need not write it always. So if you have written as log 2 only, that's enough. Sin x to the power x by and this is going to be plus 1 by log 2 base e whole square into 2 to the power x cos x is brought back, so put I over there. So same I you got back there, so you bring it back on the left hand side, I into 1 minus equal to, this thing is changed to, you take log 2 base e whole square, then 2 to the power x into cos x this minus, after simplification you will get the value of I, which will be I equal to 2 to the power x this minus sin x by log 2 base e whole square. Okay, plus c of course will be there. So when exponential multiplied by trigonometric terms are there, then integration is of this form. Now I am going to discuss the integrand of the form that where the integrand will be of the form e to the power x fx plus f dash x. See, one function is there and its derivative is there. So this is sum of two. You cannot use the same method for solving this kind of integrand. You remember that you will express it initially as the sum of two, and then use by parts for one of them, keep the other unchanged, it automatically get cancelled. So if I am using this as the integrand which I will integrate, then take fx as the first function, e to the power x as second. This into derivative of fx is f dash x e to the power x dx plus, if someone says that I'll use by parts on it, then my suggestion for them is that then you take f dash x as the second function, because its integration yield this one, it get cancelled. So the advantage you got here, if you have split it in as the sum of two integrands, then this integrand is getting cancelled with this one. The answer is fx into e to the power x remaining over there. So by now you can treat this one as formula that whenever e to the power x into fx plus f dash x is there, the answer will be e to the power x into fx plus c. For MCQ, you'll just write this as answer e to the power x into fx. But if it is a descriptive question, at least you need to mention which one fx and which one f dash x. For example, I am telling you this one, where it is e to the power x cot x plus log sin x is there. Okay, so here you all can see that derivative of log sin x, but that you need to mention when you are answering it in paper, in descriptive paper, which one fx, which one f dash x, that you must say. Here derivative of log sin x is, log sin x. If you differentiate log sin x, then this is going to be 1 by sin x into cos x. It is actually cot x. So in this case, you can write the answer as this is our fx and this one is f dash x. The answer is going to be e to the power x into log sin x plus c. Okay, so it is very straightforward. If you are able to get fx and f dash x, you will definitely write the answer as e to the power x into fx. But the question is, if it is not given in that convenient form where we can identify easily which one fx, which one f dash x. Like I am writing this sum for you. How do you do it? E to the power x into x by x plus 1 whole square dx. So whenever there is product of these two types of terms, in your mind it will first strike that I have to express it as the exponential function multiplied by sum of two. One of them is the derivative of the other. So if anybody want to write it as sum of those two, here it's going to be e to the power x Can I do it? You will ask, why have you done this thing only? Did you memorize? No. I was just trying to find a method where I can express this one, this part as sum of two. One is the derivative of the other. And probably I have got it here. I did some mental calculation. Everyone need to do that before you start the main step. You are in class 12. You can do this step easily because derivative of this is going to be this. The answer is only e to the power x 1 by x plus 1. But in board paper I told you, you should do one step here, that ddx of, since ddx of 1 by x plus 1 is equal to minus 1 by x plus 1 whole square, we can write the answer as e to the power x into fx, that 1 by x plus 1. Okay. So whenever sums are given in this form, that e to the power x into fx plus f dash x, sometimes your manipulation, your calculation may be big, but it can be done easily just if you keep the concept in your mind that I can express it as the sum of two integrand apart from e to the power x, where one is fx, the other one is f dash x. Like the sum, if I ask you, say it is x minus 1 whole square dx is there. How will you start? Is it possible to express this one as fx plus f dash x? Again, I told you to do some mental calculation. This x minus 3, you must express x minus 3 by x minus 1 whole square as sum of two. One is the derivative of the other. One can write this as x minus 1 minus 2. Isn't it? All of you must agree. So that this is changed to x minus 1 by x minus 1 whole square, that is 1 by x minus 1 minus 2 by x minus 1 whole square. So derivative of this thing is this thing. So you write this as e to the power x so this thing, now you can check here, fx is, say, so what is going to be the f dash x? X minus f dash x going to be minus so this is not changed. Probably the author has done some mistake. The sum here it will be cube, then it works nicely. Okay. Then it will be x minus 3 by x minus 1 whole cube. But this method will work nicely because x minus 1 minus 2 by x minus 1 whole cube will be there. which you express in the form as x minus 1 by this. Okay. Now you can see easily that if I have taken fx as 1 by x minus 1 whole square, then its derivative is minus 2 x minus 1 to the power minus 2 minus 1. So it is minus 2 by x minus 1 whole cube. Okay. So this thing is x minus 1 whole square and this thing is cube. Then as derivative of this is this thing, the answer is e to the power x (1 by x minus 1 whole square) plus c. Okay. Just one more type I need to discuss, might be given in your textbook, where there is a function given in the form of inverse trigonometric function. Like, say it is given cos inverse 2 by 1 plus x square. How do you do? There is no formula for cos inverse of this form. So what will you do in the first step? You will write this as pi by 2 minus sin inverse 2x by 1 plus x square. So write this one as pi by 2 into integration of dx minus sin inverse, this thing is 2 tan inverse x. So this will be pi by 2 into x minus 2 into. So same type of problem where tan inverse x will be considered as first function and nothing is there means 1 is there as the second function, and then use by parts. Okay. Thank you.